Hey, hello all. So today we'll be solving the GFG POTD. That is a problem of the day. So let's see what the problem says. The problem says given a string str, a partitioning of the string is a palindrome partitioning. If every substring of the partition is a palindrome, determine the fewest cuts needed for palindrome partitioning of the given string. So what the problem is trying to say is, given a string, if there is a string, what we want to do is we want to partition the string in such a way that each substring is itself a palindrome. If, for example, if we take an example of, uh, let's take an example here. If we take, if we consider this as example, right? Triple A, B, B, A. Now, Now let's say if we partition the string over here, right? Over here, that is one of the substring is A, and the rest of the substring is this one, right? So so what the condition is that each substring in itself should be a palindrome. Then only we can partition the string. Otherwise, we cannot partition. So if it is a single character A here, yes, as it is a single character, we can consider this as a palindrome. Then okay, then what we'll do, this substring, right? So one, this is considered as a palindrome. So now we'll move on to this next one. Okay, and then we'll go to break the uh, to partition the string again. Maybe we can break it from here, right? So again, what will be the case? A and A B B A, right? So this is another, this is again, this is a single character A, we can consider as a palindrome. And again, this itself, the substring itself is a palindrome. So if a substring or string is a palindrome, we cannot partition that further, because that itself is a palindrome, right? So how many partitions happened? If you see in our example here, uh, this one was one of the palindrome, then this one was another, and this substring was another palindrome, right? So we did two partitions. We did two partitions here, A, and B, right? So what happened was A was one, right? One of the substring, then another A was another partition substring, and then BBA. So to break these three substrings, right, we had to partition twice, right? So now what the problem states is we want to have minimum number of partitions in order to have all the substrings as palindrome. We want to have minimum number of partitions. So this was one way, right? So let's see if now with this one, with this partitioning, we got two as our partition. Now we need to see if there is lesser than two, right? So another approach was, another was, if we consider this again, A B B A, right? So another can be, we can partition from here as well, right? So A, this is one palindrome, and A, and this is another substring. So if we see, if it is a palindrome, this substring is a palindrome, we cannot break it further. And then if we consider this one, this is also palindrome, so we cannot break it further. So now what is so each substring is a palindrome which we cannot break further. And what are the number of partitions here? Only one partition. So this is the answer, right? Minimum number of partitions in order to have each substring as the palindrome. Okay, so yeah, I think you must have got the problem now. Now when we say, right, so for, if we consider the string again, so how many approaches were there? If we go down again, the right. So what was our example? So yeah, so A B, and what was the example here? Yeah, BBA, right? BBA. So first we did partitioning right here, right? And this was the approach, right? One plus and the rest of the substring, right? Then the second one was partitioning from here. The second partitioning was A, right? So the partitioning was here. The second one was right. So 1 plus this is one, consider one partitioning one and the rest one, right? So if we see, right, in order to solve this problem, what comes into the mind? What approach comes into the mind? So yes, if you've thought this, then it is recursion, right? Because you have to find all the possibilities, okay, and to find out the minimum number of partitions required. So in order to solve this, we'll have to solve this using recursion. Okay. So if you see how to proceed, right? So we consider one as a partitioning, right? If it is a palindrome, then only we can consider the rest of the string, right? So what we'll do, if we partition this one, then one, and then in the function we have to pass the remaining one, right? We have to start, for example, if we consider this as j, right? This as j, okay, and okay, so we have to move like this, right? We have to move like this, and we have to keep on partitioning each substring, and each substring should be uh, a palindrome. So let's see the code now. We'll solve the code. Maybe you'll understand it better then. Okay. Let's go to the code. Yeah. Now what we'll do here is, for example, int n equal to str.length. Okay. Then what we'll do is we'll write a function. Let's call it this. When it will pass it 0, n, the length of the string, and okay, as it is a static, we'll have to return f. Let's consider int I, n, and string str. So now what will be the base condition? Let's write the base condition later on. So let's first write what we want to do is we want to move in j equal to I, right? Which is j is nothing but it is I is nothing but it is starting from 0, and then we have to move it, move ahead, right? And what should be the case? This j equal to I. So now if we are starting, um, just hold on, is palindrome, right? str I j, right? If it is palindrome, then only if it is palindrome, uh, right? If now we are starting from 0, right? If it is palindrome, then we have to proceed further, right? So for example, if AA, if if we consider this as an example, right? A. So this is not a palindrome, right? So we have to start from zero, and then we have to proceed further, right? So let's see now. So is palindrome, if it is palindrome, then we need to consider the cost. So 1 plus, then we have to send the rest of the string, right? Send the rest of the string 1 plus j, comma n, comma str, recursion, right? In the recursion to find the further partitions. So if we consider this, right? If we had broken this, right? A we had considered this is a palindrome. A definitely it's a single character to palindrome. So we consider 1, okay, as a partition, and we are sending the rest of the substring now, okay, for further partitioning. Okay, if, partitioning is possible or not. So we are sending the rest of the string now, f j plus 1. So we are sending from, yeah, this one. Okay. Okay, so we have to consider cost, and now what we want to do is we want to find minimum cost, right? int min cost equal to, let's consider integer dot max value. Min cost equal to min cost, right? Sorry, math dot min cost, comma cost, right? And then what we need to do, we have to return min cost. So now, yes, so if you, so what we are doing here is we are proceeding. So from zero, from the zeroth index, and then we are calculating all the possibilities. So first we'll break this, then we'll break this AA, right? And then we'll send the rest of the string. Okay. So in that way, whatever is the minimum cost we get, right? So we are considering that and returning. Okay. So let's see return. And what will the base case here? Definitely the base case would be if I has reached till n, right? So we want to return 0. Okay. So if we consider this, let's compile and run, getting the answer. Oh, oh yes, we want to implement palindrome as well. Static boolean is pal, then string str int I and int j. What will be, we have to, this is a very basic function to solve. So we want to move, we have to compare the start and the end characters, right? I would be the start and j would be the end. Char at j, right? If they are not equal, that means that it is not palindrome. So we'll return false. And if it is, if the characters match, then we have to increment and decrement the counters. And finally, we have to return true. That means the complete string is a palindrome. Let's see. Oh, yes. Now, one more thing. Our solution, it is written in 4. So what is happening is our solution, if we consider right here, so if we consider this, so what is happening? Let's consider this small string. So our code is doing what? It is doing partitioning here, here, and here as well. So here it is not required. So what we'll do, we'll simply, yeah, we'll simply do -1 so that it works. It is written 3 now. If we submit, let's see if the solution is accepted. Okay, so we have got TLE. Okay, so now why we have got TLE is because um, yeah, because what is happening is it is exceeding the time complexity, right? It has become exponential now. As a lot of there is overlapping sub problems, right? So whatever the expected time complexity, it is going beyond that. So here the expected time complexity is O of n into n, right? So it is going beyond that. So now if we see, right, there can be a lot of overlapping sub problems. So when we think of overlapping sub problems, then memoization or DP comes into mind, right? So what we'll do, simple, we'll do memoization int DP equal to new int n, right? So why only single dimensional array? Because single dimensional DP is because we have only one variable, that is I, right? So that is why single array, single dimensional array. Let's fill it with the DP of -1. We'll pass it here DP and int DP, right here. So simple, what we'll do is we'll return like this: DP of I equal to min cost, and here we'll just check if the problem is already solved. If it is already solved for that is not equal to -1, we have come across in, then we'll just return DP of I. Okay. So now let's see if our solution is accepted. Okay, what we have missed here. Okay, we have to add DP here as well. Now let's see. Yes, the solution is accepted. And the time complexity, what we are getting is O of n square. One is this loop, that is O of n. And then for each, we are again calling this function, right? So that counts for another n. Okay. So this is the time complexity and space complexity as well. Yeah, we have taken extra space, that is dp, right? And then we have auxiliary space as well, that is the function stack. Okay. So thanks for watching. I hope uh, you have understood the solution. Thank you so much.